Assalamualaikum and a very good day to my panels. My name is Aidil Amirul Azad bin Arzhad, and today I would like to present my proposal for final year project 1 on this semester. My project entitled as Karakuri Packaging for Small Packaging Box. First of all, I would like to express my gratitude to my supervisor, IR Dr. Noor binti Muhammad Salleh, and my co-supervisor, which is Dr. Farrahshaida Muhammad Salleh, and for helping me out and guiding me throughout the whole process of preparing this proposal. So let's begin my presentation with the key points of this presentation. We will be discussing about project summary, introductions, literature review, problem statements and objectives, scope and limitations, methodology, and preliminary results. First and foremost, I will brief explanation about my project summary. The purpose of this study is to design and create a machine that automatically puts small products, which is stationery and phone holders, into small packaging box using the Karakuri method. The machine will use roller conveyors and electrical components like Arduino Uno, ESP32, ultrasonic distance sensor, and stoppers to move the products through the production line using gravity. The workstation will be designed using CATIA V5 with kinematic simulations to test the flow of the workstation when the Karakuri method is applied. The initial findings show that it is challenging to use the Karakuri method for light products as it is typically used for heavy products. However, this study will demonstrate that the Karakuri methods can be cost-effective and flexible alternative to conveyor system in industry, reducing the cost of operators and maintenance while improving ergonomics working conditions. For the introduction, Karakuri is a type of automation that uses natural forces like gravity and human effort instead of electricity to operate. It employs mechanical elements like pulleys, gears, and links but does not require electrical components. The Karakuri Kaizen movement inspired the Karakuri Internet of Things project, which aims to improve work processes through small, continuous improvements known as Kaizen, which are intended to simplify work, increase efficiency, and enhance safety. These efforts results in the creation of simple machines that make everyday tasks easier. This approach, also called low-cost intelligent automation, is used to create practical solutions with minimal resources and can improve process availability by reducing complexity. Besides the smart conveyor used in many industries, it is made up of detachable workstations and employs the Karakuri method for operations. Gravity roller conveyors are used because it is useful and inexpensive tool for quickly and easily moving a variety of materials without the need for power. In this project, the Karakuri Kaizen method is used to assemble the product and then it is checked for defects using AI. If defects are found, the product is sent to a defection box. If the product passes inspection, it is placed in a packaging box. The packaging box consists of two workstations, a small packaging box stacked with 6 boxes and a large packaging box for delivery to the customer. The Karakuri devices are used in a variety of industries to make operations easier, more ergonomic, and more efficient while also minimizing energy use and environmental impact. This device has been particularly popular in the automotive industry in the recent decades, with the companies such as Toyota, Daikin, IC Senki, and Honda. Next, we go to the problem statements. Currently, products which is stationery and phone holders are placed manually into small packaging boxes. The design for this process will incorporate the Karakuri concept despite the challenge of using this method for light products, as it is typically used for heavy products to improve ergonomics. And as for the objectives of this study is first to study and benchmark available automated packaging system in the market, to design and develop an automated Karakuri packaging system for small packaging box, and to fabricate the automated Karakuri packaging system for small packaging box. For the scope and limitations, this study will focus on automated conveyor systems that use the Karakuri method, which employs system machines and mechanisms to move materials along a conveyor belt and perform tasks such as sorting, labeling, palletizing, and packaging. The Karakuri Kaizen method is allowed for easy modification or expansion as needed. The system will be composed of a production line with roller conveyors and electrical components like Arduino Uno, ESP32, ultrasonic distance sensor, and stoppers, and it will use gravity to move the products from one station to another. The workstation will be designed using CATIA V5 and tested using kinematic simulations. Next, we go to the limitation of project. which this approach may not be suitable for complex products or very large-scale operations, and the initial setup and design may be costly due to the time and resources required for planning and design. It is also limited in flexibility and scalability, making it more suitable for small or medium-sized businesses. Additionally, semi-automated Karakuri systems are not as wide used as other automation methods due to their limited support and resources for troubleshootings and maintenance. As for methodology, this study starts with reviewing research papers, articles, and benchmark other available smart packaging systems in the market that related to this topic. The design begins with sketching based on fundamental knowledge of Karakuri concept. There are 5 basic mechanisms of Karakuri, which are pulley, seesaw, rotation, slider crank, and slide stroke. But in this study, only focus on slide stroke, which is pushing the top and the bottom packaging box from the inventory box. To sketch the design of packaging workstation, the consideration of flow and layout of workstation must be taken. The concept emphasizes the use the electrical devices, automations, and optimize the packaging processes. From sketching several designs, the best design is selected based on bar chart to be converted into 3D model which using CATIA V5 software. As the result, by following the engineering design process, the design of workstation can be improved from the current situation. This is the bar chart that I made, which is the A products, the A design is a datum, B and C is the selection that I have to choose whether one is better than another. So the criteria is basically with the convenient, the cost, response times, maintainability, easy to implement, and other else. And then total the plus and total the minus, and then the overall total again for the design B. By using the kinematic simulation and Blender software, which the kinematic simulation can be get from CATIA V5, and the Blender itself can be made from a 2D drawing to a 3D model. And then configuring the simulation, observe how the model responds under various conditions. Once the test is completed and every part of the workstation works properly, the design will undergo fabrication process which involve all the essential equipment and supplies such as Karakuri pipes, screws, bolts, and any automation equipment for fabrication process. And once the workstation has been assembled, it is then tested to check if all of this function works properly and satisfies all of the required specifications. The methods of this research is presented by this flowchart, which is start with literature review and then implementation of Karakuri method, and then start designing packaging workstation to converting design into CAD or computer aided design in CATIA, and then from the CATIA itself we use the kinetic simulation test to test the design, and then if every part is working properly, and then we go for the fabrication process, which we realize the product from the 3D models, and then the fabrications can be made or refinements or modifications if there is need to revise or repairings. Next, we jump into the expected results. The purpose of using CATIA V5 software for designing the packaging workstation is to simulate the Karakuri concept and apply them into the workstation through kinematic simulations. And the conveyor system of the production line are using gravity roller to let the product drop from the inventory to every workstation. Karakuri Kaizen method is also implemented along the production line to achieve the design of the packaging workstation by using semi-automated Karakuri system. Last but not least, the preliminary results for the study that the figure has shown, which is the sketch design of the packaging workstation that has been selected during this methodology, which is design concept B, the conveyor system from the previous section, which is responsible for quality control or artificial intelligence. It will use gravity to feed the products to the packaging workstations. This conveyor uses rollers as a base, and the product will follow the line until they reach the sensor in front of the bottom part of the packaging box inventory. At this point, the sensor will detect product and it will automatically drop onto the bottom part of the packaging box. The roller will then take the bottom part of the packaging box under the top part, followed by a stopper to keep the product from sliding straight into the next workstation. The top part of the packaging box will then be placed on the bottom part, and the packaged product will be ready to move on to the next workstation, where it will be stacked into a large packaging box. Then that's all for me. Thank you and have a good day.